here, we want to graph the functions f of x equals 2 raised to the power x and g of x equals 1/2 raised to the power x. So when it comes to learning how to graph this stuff, there's nothing to do but practice. Get ourselves some examples here so we know roughly what's going to happen. And I'll say here that when we're talking about these functions, talking about these graphs, you might think to yourself, hey, that x can be anything. So are we going to have to deal with finding places like 2 raised to the power 0.0725 or like 1/2 raised to the power -8,000? No. Look, I'm not the stickiest when it comes to details for graphing. The main thing I want you guys to be able to do here is take functions like that, which probably at this point aren't that clear in terms of how they should picture, how they should come out, and get a sense of what they're supposed to look like using some basic points that we usually graph things. It's not so much about getting every single detail exactly right as it is knowing, hey, this thing goes up in one direction, down the other, or what have you. Just get a good sense of what to expect here. So for that 2 raised to the power x, what we're going to do is take some basic points there, plot those points out, and use them to make ourselves a nice, clean picture. So we're going to take the points x equals -3, -2, -1, 0, 1, 2, and 3. And you can take a little bit more, a little bit less, depending on how confident you are. But we're going to evaluate our function at each of those locations, where at -3, we would get 2 raised to the power -3, or 1/2 cubed, which is 1/8. Then at -2, we would have 2 raised to the -2, 1/2 squared, which is 1/4. Then at -1, just flip it over, you get 1/2. At 0, 2 to the 0 is 1. At 1, 2 to the first is 2. Then 2 gets you 2 squared, or 4. 3 gets you 2 cubed, or 8. And you take those 6 points, you plot each of the 6 of them out, and you pull your curve through it, and you get something like that. It's pretty simple. It's what graphing always is. You know, people get very, very nervous about graphing. Just find points and play connect the dot. Don't get too nervous about it. It's not that bad. Then, for our second example, for dealing with g, there are a couple things we can do there. For one, we can notice that if we have something like 1/2 raised to the power x, that's the same as 2 raised, oh, I'll put that down there, that's a little bit too low, 2 raised to the power -x. So we can talk about evaluating this at those points by throwing in some double negatives everywhere, that we would have at -3, 2 raised to the -3, at -2 it's 2 raised to the -2, -1, 0, -1, -2, and -3 in that way. Or we can look at taking these in terms of just powers of 2 on the bottom. There are a few different ways we can look at this sort of thing. Probably the easiest way to get our picture, though, is to understand that with both those points and those points, that essentially what we're doing there is one of those reflections from way back when we were talking about transformations. That if we have this picture in mind, instead of plotting all of those points bit by bit and then playing connect the dot, which you can do, it's perfectly valid, we could also just look at taking that picture and flipping it over the y-axis because we threw in a -x. It's exactly the same function up to that reflection where we get what we're looking for. And that's how the graphing here goes. So to help us understand this a little bit better, we're going to talk about some of these characteristics for how these kinds of functions act in terms of things like the transformations.